Hi, my name is Steve. I'm doing the competitive project on cryptocurrency, the price of Bitcoin. So first of all, I've just got an overview of the series here. So this plot here is the plot of the whole series, and this is just a zoomed in section of sort of this area down here that's a bit harder to see in this main plot. So from the two plots, we can see there's obviously trend apparent in the series. There's changing variance. The variance in this section looks much greater than the variance along this area, and there's no clear signs of seasonality. And the correlation between consecutive days is very high, which we would expect. That's at 0.997. So now we'll have a look at the ACF and the PACF, and the decaying pattern in the ACF and the high initial lag in the PACF supports the fact that there's trend in the series, and the ADF test gives a p-value of 0.7. So at this stage, it looks like the series is non-stationary. So just before going ahead with applying transformations and differencing, I've just tacked on a couple of trend models here. Obviously, they're not great models for this series, so we'll go right on with the transformation first of all. So I've used a box-Cox transformation with a lambda value of negative 0.395, and then applied first difference, and that gives us this plot. And it does look like the series has been detrended, although the variance is still does still change, and but we do now get a ADF p-value of less than 0.01. So now looking at the ACF and the PACF, there are definitely still some significant lags, although not too many. This is just a close-up of the first little section of both plots. So they look okay. And now here we can see in the EACF, it's not all that clear here, although it does look like maybe we can use a 1-1 model. And then over here, it looks like we can look at using an error of 6 and maybe a lag of 4, but that's not all that supported. So we can play around with that with the models. So because of that, first of all, I've had a look at an ARIMA model with a 416 model, and that has given variables that aren't significant. Most of the variables in that are not significant, but we'll have a look at the residual analysis, and it does look okay. Obviously the QQ plot here departs from the QQ line at the tails, and so there's possible departure of normality there. But overall it's not too bad. this is sort of normally distributed. The histogram, the ACF and the PACF look okay. There's significant lag here, but overall not too bad. And the test down here, there's no significant values there, so that's okay. But because the variables weren't, the coefficients weren't significant in this model, we'll remove some of those values. And going down, the next one, the model I found where everything was significant was the 213 ARIMA model. So I've had a look at the residuals of that model as well. Again, the histogram looks good, and it's the same situation with the ACF and the PACF. There's a couple of significant lags, but overall it's fairly good. QQ plot is the same as for the previous model, the departure at the tails. But then looking at the box test here, there are, sort of after the fifth value here, there are significant significant in the p-value test. So because of that, we may lean towards the 416 model, but I will go ahead and look at both. So I've got the forecast here with the 416 ARIMA model, and I've got a plot of the whole time series, and then just from 2018, so we can see the forecast a little better. Obviously, as we'd expect with a time series as volatile as this, the confidence intervals are very large. We've got here for the next 10-day forecast that the forecast is relatively steady, but then the confidence intervals span a huge sort of area, all the way up to over sort of $40,000 up here. And we've got a MASE value of 3.74 for this model. And now we've also got the ARIMA 213 model. Same situation here. This is the whole series, and this is just a zoomed in version of 2018. Again, confidence intervals are very large, but it looks as if forecast is slightly, obviously it will be slightly different for this one. And this model's actually given us a MASE value of 3.69, so actually a better value for this one. So that's the model we would look at using with the better MASE value, and that's the best model that I was able to find for this time series. Thank you.